All right, hi everybody. So in this little video here, we're going to simplify this rational expression, and I'm just going to jump right into it. Away we go here. Now, before we get too far into this, I want to just point out a little mistake here. Notice that the x to the -1 plus the y to the -1 all over x to the -3 plus y to the -3. Notice all the negative exponents that are in there. It would be a mistake to believe that the negative exponents cause these things to flip. For example, it would be a mistake to think that this is actually this. Okay. Um, I know what the rule about negative exponents is. It pushes these terms to the other side of the division symbol here. But the thing is, the division symbol there implies a set of brackets around the expressions in the numerator and the denominator. And so the addition here has to happen before we can start jumping across that division symbol. So really what this looks like is it's more like this. It's 1 over x plus 1 over y, all divided by 1 over x cubed plus 1 over y cubed. That's what this question is asking. And so now in the numerator, the common denominator is going to be x multiplied by y. So that means I'm going to have to multiply numerator and denominator here by y, numerator denominator here by x. In the denominator is the same sort of thing. This is going to be y cubed, over here x cubed, x cubed. And so what I'm going to get here is I'm going to get x, y, and then I'll get y plus x. Now I'm going to change the order of that in just a moment here. And then down in the denominator, it's going to be x cubed, y cubed. And again, this would be y cubed plus x cubed. And just for fun, I'm going to change the order for no other reason than it looks better if it's alphabetic. Now, at this point, I've got a fraction divided by a fraction, and I know that that means I multiply by the reciprocal. So this is going to be x plus y over xy multiplied by x cubed, y cubed, okay, over x cubed plus y cubed. Now I can see a little bit of canceling that's going to occur. Okay, can totally see that. But I need to do a little bit more factoring here. So this is going to be x plus y over xy. Can't do much with that. But over here, this is going to be x cubed, y cubed. But notice in the denominator, I've got this sum of cubes. And so the pattern here is going to be that this will break down into x plus y multiplied by x squared minus xy plus y squared. Now, bear in mind here, and you're probably recognizing this right off the bat, I'm assuming that you have seen this before. This a cubed plus or minus b cubed is the same as a plus or minus b multiplied by a squared minus plus the sign changes ab plus b cubed. Now, I'm assuming some familiarity with this sum or difference of cubes here. Now, at this point here, we can do a little bit of canceling. That x plus y is going to cancel with the x plus y. And then one of the factors of the x, one of the factors of the y is going to cancel. And so we are going to be left with x squared, y squared over x squared minus xy plus y squared. And that really is not going to factor down nicely. Anything that we would do kind of from this point on to factor that is going to introduce some ugly numbers here. So that's where we're going to end it. We will say, though, however, there are a couple things that we want to point out here. After we started canceling stuff, for example, I know that x can't equal 0. I know that y can't equal 0. Okay, I get that from this part of the expression right here. I also know, based on what I canceled here, that x plus y can't equal 0, which basically means, if I want to simplify that down, x can't equal negative y, or y can't equal negative x, however you want to do that. Okay, these are just some of the restrictions that pop out because of the canceling that I did. There are other restrictions in there, but they're still there in the final expression. So anyway, there you go.